Hello everybody who's joining today's webinar. Welcome. And now we're going to be learning about some J750, some of the different approaches today that we can do color applications on those. Jumping through the marketing stuff here, who we are at GoEngineer. GoEngineer provides design and manufacturing tools with expertise that enables customers to reduce the cost, risk, and time required to go live with new technologies and ultimately make new products introductions. Just to kind of simplify that, here at GoEngineer, we really specialize in a whole host of engineering tools and services that would go along with those tools. So on the design side of things and the software side of things, we're really all about SolidWorks and some of the related product data management capabilities that are out there to help people as they're building and collaborating on these giant design files, that there's an ecosystem that allows people to not step on each other's toes when it comes to design. As we move a little bit more to the hardware side, we focus with Stratasys 3D printers, desktop metal 3D printers, Creaform's full line of scanners, and we do lots of different services on those different hardware products. Jumping to specifically today's presentation, we're going to be looking at color application methods for the J750 printer. For anyone who doesn't know, the J750 printer is Stratasys' 6-color printer. What allows us to load us with 6 different materials at one time, which, if we imagine cyan, magenta, yellow, black, white, clear, that allows us to do full color prints. For me personally, about once a week, I have someone come to me or one of our sales reps out there who working with a customer who's a little bit confused about the different ways we can apply colors and the different ways that full color 3D printing is approached. So that's really where this webinar today spawned out of. Today, we're going to look at shell-based color selection, and that's working with STLs in the GrabCAD print software. For anyone who doesn't know, the GrabCAD print software is the print driver associated with all of Stratasys' newer systems. The modern user interface, the color selection tools are way above anything that existed before. We'll get to see that in action today. Next, we're going to look at CAD color selection right within SolidWorks, and we at GoEngineer are most familiar with. We can also do that color selection in GrabCAD print using our CAD files. So we'll show both approaches as we run through the exercises today. The third topic is going to be CAD-based simulated image textures, pretty much kind of a workaround approach where if we're trying to simulate pad printing and other things like that, we can apply simple images to CAD models and then print those on the J750. Next is going to be image-based textures, commonly known as VRML files. These are files that have a 2D texture map image associated with a 3D piece of geometry that really maps each node in the mesh to a specific color that allows us to generate a full color model at the end. We're going to go over in that kind of the ways in Photoshop that we can apply these textures to models. Next, we're going to look at directly importing VRMLs from other softwares beyond Photoshop. And as we look at other things like Rhino and 3D Studio Max, softwares that I'm not an expert in, but we'll look at some of the more complex VRML files that can be created in those types of software. And then last, we're going to look at an approach for hard color proofing using the Stratasys swatch generator tool. Color proofing is we have a color in mind, we have a look in mind, and what we're really trying to do is match the output of the printer to whatever pre-specified color sample we might have in hand or some other master proof that we're going to use to try to get as close as we possibly can to. Now that we've kind of gone over the topics, I'm just going to go ahead and start with topic number 1. The first step to doing all of this will be to open up the GrabCAD print software. So let me go ahead and open that up. Okay, you should see on my screen now the GrabCAD print application with a J750 tray loaded. The first step in this is to really configure our printer. So if we look at the current material I have, the materials loaded are not full color materials and would not enable full color printing. So we want to remove all those, and then generally speaking, the preferred palette color printing with rigids is cyan, magenta, yellow, black, white, clear. And those will allow us to do pretty much anything we can imagine or design in any of the different softwares that we're going to be looking at today. So I'm going to set that tray up. There's clear added, there's cyan added, there's black added. Let's see, Vero Pure White we want to get in there. And you'll notice that for the magenta and the yellow, there's a little V added next to those. What those refer to, and you'll notice there's also a yellow without the V. Just recently, Stratasys reformulated the colors to widen what's called the color gamut. I will talk a little bit about that before the end, what a color gamut is, but essentially it allows us to print in a wider range of colors. So it was just a slight reformulation of the colors to unlock the maximum capability there. So there we see the loaded 6 materials. This is a machine that can operate with up to 6 materials, so everything looks pretty good and straightforward there. And then what I'm going to do now is load in a series of STL files that represent a single assembly. This is the way that we would have been doing it on an older Connex system 3-4 years ago. For the most part, I think some of the other methods we're going to look at today have sort of superseded this approach, but as you can see in this example, I think it might apply in some cases to medical models 3D printing, where the export from raw DICOM data or something like that is essentially meshes, and our goal is to print these meshes in different colors to highlight different things. So the way we're going to do this is File, Add STLs as Assembly, and then we're going to go ahead and browse for all of the files we need. So in this file, you can see that each component of the STL assembly already has a material called out in the file name, so that's going to make it real easy for me to go ahead and apply exactly what's called out. So with everything selected, I hit Import, and there we see the representation of the file itself. I'm not 100% sure what the errors are with these models or where they possibly would have came from, but this is a feature of GrabCAD Print that is a little bit newer, and it's got some mesh repair capabilities built right in there. So I'm going to go ahead and run the mesh repair wizard and allow it to take care of everything. There we go. So we see all those error messages have gone away and everything's happy now. So the first step is to apply the materials according to the name. So I see the clear there, that's reaching out to me. So I can go ahead and, let's see, that's Vero Pure White. That's the clear right there. And this is something that GrabCAD Print has already identified, the fact that clear is not visualized. So for this particular instance, just so I can see everything else I'm working with, I'm going to go ahead and hide that now that the clear material assignment has been made there. The next material we're going to do, I see this is called out as being in Vero Cyan, so that's as easy as select the model, select the base cyan material. Again, with magenta, select the magenta component, and select the base material. So this is all straightforward. The last 3 here, you see MT and CM. This refers to what's called a digital material, or a mix of 2 of the base resins. So in the case of CM, it's cyan magenta. Again, another different variation of cyan magenta. And then this one here is magenta and translucent. Obviously, that's going to be magenta and clear. If you could see if why translucent instead of clear, well, because then it would be an M and a C, and C represents cyan. So let's go ahead and start. And now we're going to make our selections not by the actual tray materials loaded, but we're going to go into this DM color picker, or this digital material picker. And then we can look at the different combinations of base resins and the different permutations of combinations that exist with these 6 color materials. So I'm looking for a cyan magenta or a magenta and clear. So here I see the cyan magenta right there. I'm going to pull that up, and with the cyan magenta, whoops, I was on the one that should be magenta tango. So let me go now, recall up that cyan magenta. There's other tools out there that we'll highlight as we move through these exercises. So this is CM005. So there is 2, 3, 4, 5, kind of a purple color. And we saw that that element of the STL assembly now has taken on that color. Next, we are going to go with CM002. So again, cyan magenta 002. Which is this guy here, cyan magenta 002. And the last one is the magenta translucent. So magenta and clear is what we are looking for. And there's clear and cyan, not going to help us. Cyan and magenta, clear and magenta. There we go. So this one is MT002. Okay, so now we'll see that each of these different components of this assembly have gotten their digital material or just singular base resin color assignments. That done, we can then reactivate our Vero Clear outer piece. And this is ready to print. Again, just to reiterate what we've just seen, it is the shell or STL based color selection within GrabCAD Print. Shifting gears now a little bit, we're going to talk about color selection in SolidWorks and GrabCAD Print. So let me go ahead and browse for a file here and go ahead and open it. This is just a SolidWorks part file that has multiple bodies. It could just as easily be a SolidWorks assembly file. So I've clicked it here and you can't see on my other screen, but now SolidWorks is going to go ahead and open. So I guess step one, I can show you a simple approach with that without even adjusting anything in SolidWorks. We can actually bring in that file right here, going to the GoEngineer logo, and we'll notice that it's just all kind of that default SolidWorks gray color that we typically see. And we see the file here, so you'll notice it's just the different bodies. So what I want to do is assemble this to actually produce the logo, and we can orientate this around, play around in X. So moving beyond the DM digital material color picker that we have this other color picker tool, which allows us to kind of pick off of a color gamut and then apply colors this way. So if we want to, we can pick those. I apologize to any GoEngineer marketing people. I know I'm butchering our official colors. For demonstration purposes, I think this is important. So, you know, we can really just pick anything we want. The challenge with this is if we ever want to reprint or, you know, we're just picking one at a time from the color picker, and I'm glossing over many of the color picking tools that are available. I promise we'll show these a little bit more detail and the ability to specify by RGB or LAB or hex values, but pretty much it's as simple as select an element, select a color on the screen that we want. We can see a hex value for that. If we want to go and enter RGBs for these colors, we can do that as well. I'm just going to guess 120, 15, and making a random number 45. So again, there's kind of a random color here, and you can go and select this for all the bodies. You get the idea there. The problem is if we ever want to duplicate this or edit this, all of our changes have been made in GrabCAD Print, so bringing in a new instance of this SolidWorks file will mean all of this work needs to be duplicated again. The workaround from there is to do this work right within SolidWorks itself. So SolidWorks is nice and loaded now, and I will bring this over here. So looking at this, we'll see that I can pick individual bodies from this file and apply the colors right within SolidWorks at the body level. So I can do a green here and a yellow there. Whoops, I got both bodies selected, so let's not do that. Let's do one at a time. So I have a green there, maybe a slight variation with a yellow color, and we'll do two yellows for that one because I clicked a new body without controlling that. We can do another green here. Maybe pick this guy, and I'm not going to demonstrate all of the SolidWorks color selection tools because I don't really want to make this a SolidWorks exercise, but really just to show that SolidWorks gives us a very high level of control for what we can do. And so now I do File, save this guy, and we'll see that when I bring this into GrabCAD Print again, what we have is Add Models. I've now saved the updated version. We have all of our colors applied. So it should be fairly obvious at this point. The preferred method would be to make our color applications in the SolidWorks level. And that way, anytime we bring this into GrabCAD, we find that it's already good to go. One of the limitations I want to mention with this, though, is this really only applies to singular opaque colors. So if I go back into here in SolidWorks and I try to edit a material, let's do a wood for lack of better terms. So we see now that except for where we've applied other colors, we have a wood grain on there. Looks really cool in our SolidWorks screen. But if I save this and I attempt to re-import a new version of it, you'll notice that my wood grain does not come through. This is just kind of a known limitation right now with what SolidWorks can do, and it has no functionality for exporting these complex textures. I have heard that GrabCAD Print has OBJ kind of on its radar and the ability to accept OBJ files. Separately, there are plugins we can use within SolidWorks to export that wood grain that we saw as a function, in the OBJ format. So at some point in the near future, that might be a possibility to include wood grain or carbon fiber or anything like that right out of SolidWorks. But as of right now, we're going to need a Photoshop or something else to do it, which will get demonstrated in the subsequent exercises. There we have these ones. Let me just orientate this guy, roll it about X. Okay. So, and what I'm doing, I'm just going to be building up this tray of all these different part files. So when we're done, we can kind of look at the complete tray of everything that we've demonstrated. In the next scenario, jumping back to our, the next scenario we're going to be looking at is the scenario 3, the CAD-based simulation of image textures. So for this, I kind of think of maybe if you're doing like display buttons and we want, to simulate a pad printed element. So just one sort of picture is, let's just pretend that maybe your marketing folks gave you something like this and they're saying, hey, we want this logo put right here on this 3D file, something that would be pad printed. Now we can do that as an image texture in something like Photoshop, but if you don't have Photoshop or maybe you're a SolidWorks wizard, there's a SolidWorks workaround we can do that. So essentially the first step in that would be to create that feature as a portion of an assembly within SolidWorks. So here we see what I did is I essentially took an image sketch, created it essentially as a feature, cut it into the model, did some Boolean subtraction features, and now I have an assembly where that pad printing element is represented as its own body. From there, I think you can draw the quick connection as to how easy this would be. So I can go right into GrabCAD Print. We'll go Add Models, browse for this, and we couldn't do it from the shell level, which the STL level, but I think it's easier if you have SolidWorks already, skip the whole STL export and bring in the SolidWorks assembly file. So there we see the model kind of brought in, but you'll notice it is loosely disassembled. So we just check these boxes and suddenly their whole assembly comes back in with all the bodies right where they should be. So on the outside, I'm just gonna, you just use a color picker here to say, give me a really red here. You'll notice that the red that came in was actually the sort of a red from SolidWorks, although in SolidWorks, I had this as a transparent model, and you will notice that we have lost all transparency as we brought it into here. Not a big deal, but next, I want to point out how we're going to make this a different color. But if we go back to that original image, you'll notice that they call out this color like a Pantone 877C. There's different approaches, but to doing this, I'm just going to Google here Pantone 877C, and you'll notice that it gives me different formats for this, a hex format and an RGB format. So I'm going to copy the hex just because that's convenient and on top, but I could just as easily write down those RGB values. And if I go back to GrabCAD Print, you notice we have this option for putting in a hex color just there, and then obviously we can do RGB colors right there. So we can input this any way that we really want to. There's a few different color methodologies. I don't consider myself a color expert. I'm not going to pretend to try to explain to you what LAB and RGB and CMY and all of those are in this webinar. So here we see we have that part with that color as specified by maybe our marketing or other group to kind of give us a good representation of the pad print right on the part there. This is, again, what I call a workaround for actual texture application. We're not getting to VRML and 3D texture files just yet. We're using all shell-based approaches. Jumping back to our slide, so that was kind of the CAD-based simulated image textures approach. Next is going to be image textures or VRMLs applied right within Photoshop. I'm not a Photoshop expert, but I know enough to get myself into trouble sometimes, so let me attempt to do that right now. Let me launch my Photoshop. For this exercise, what I'm going to do is I've prepared CAD. You'll see in this in my example files where I have an STL and a SolidWorks file of kind of a globe and a base. It's really just a sphere, and we can open them up in SolidWorks so you can see what I have. But it's essentially a sphere and then a little rectangular prism cut out like a base. And what we're going to do is do this globe with a wood grain base, and then the globe is the sphere wrapped to a 2D image of the Earth. Jumping back over to SolidWorks, here we see the globe base, fairly straightforward. And the sphere is, as we can imagine, just a sphere. Jumping out of those, I'm going to bring in Photoshop here. And step one with Photoshop is just kind of open up a new workspace. So you can't see it on the screen, but I'm going to select just 1000 DPI by 1000 DPI workspace. One of the options here, so first we want to bring in some geometry. So in this case, it's a sphere. This was actually a default sphere right within Photoshop because it has some basic geometry. So I'll just work on that, although I could just as easily have used a different sphere. So now that we have a sphere, what we're going to want to do is select the texture. So as a default, it's just a white sphere. But if I jump over to Edit Texture, we'll go to Edit Texture. You'll see now we have the flat pattern image of the texture that's being applied to this sphere. I can then jump over to my old friend Google, and let's just Google NASA Earth Map. And images, and this one here looks like it will work, so we'll save image as desktop. And we're working on the J750 color selection webinar, and this is the globe with wood base. So Earth image, we'll call it. How creative, right? So we've saved the image. So now what this is going to want us to do is, we can select an image or just drag and drop an image. And then what we want to do is apply the image to the entire background area. Accept the image, and if we jump back to our sphere, we noticed, voila, there we have the image version of this sphere kind of wrapped to the 3D geometry here. Not to oversimplify things, but Photoshop is not always the best tool as your geometries become more complex. This is a sphere, so this is very simple. As I've learned by struggling over the probably past 6 months, there are better softwares suited to this like Rhino or 3D Studio Max, but I'm not an expert and don't have access to those, so I'm just kind of showing you the simplest case with the things I have available. From here, we can go to 3D Print, which essentially initiates an export wizard here. Can't see it, but it's repairing meshes and doing that on my other screen. But with that, I will keep plugging along. And this is really Photoshop thinking right now. Oh, at least we can see that on the screen. So it finished, and there we see the actual representation of the model itself. And we will go ahead and hit Export. And we'll see we just have to give it a name. So I'm going to we'll call it Globe Sphere. And I'm going to throw it in the folder we're working out of today, which is Globe Sphere WRL. So notice now we're working on a WRL file. It comes from the virtual reality modeler language is kind of what that stands for. Used a lot in video games and other things like that. But essentially it's a mesh file that then has all of its nodes mapped to a physical like 2D image like a PNG or a JPEG. As I go to open this in GrabCAD Print in a second here, this WRL file is going to call on this sphere PNG file, which tells it how to color each node in the mesh. So just to demonstrate that, we will go to Add Models, Globe with Wood Base, Globe Sphere. And there we see that in there. I didn't really pay attention much to scaling this exercise. I think I might, I set it up for the base to be for a 2.5-inch sphere. I think this is a little bigger than that, so I'm just going to do this at we'll do like a 50% scale just to bring it down to something appropriate. Again, if you were paying more attention along the way, you would have that. So there we can see we have the full image texture that we just downloaded from Google wrapped to the surface of the sphere. So the next step will be to maybe apply a wood grain to the base. For that, I will jump back into Photoshop here. Let me close this so I don't consume too much of my computer resources. Yeah, we can save that as a Photoshop. Sphere, save that. And no on there because we're already mapped to it. Okay. Next step here, what I'm going to want to do is create a new workspace again. And from now, what I can do is drag in my my mesh from the globe base. And it's asking me units. This is where I think I might have gone wrong on the sphere by not checking it, but this should be in inches. This whole thing is 3 inches by 3 inches by 3/4 of an inch. So once I do that, you'll notice that we have the actual 3D model there, and right now it has a white background, so it's a little tough to see. But what I can do is, first we need to get a wood grain image to use on this. So back to our friend Google Images, and we'll go wood grain image. You can see I was practicing today before. Doesn't really matter. Save image as. Hopefully it's sufficient on the size, but we'll call this wood grain JPEG. Okie dokie, we have something saved. I'm sorry, Photoshop, not GrabCAD Print. So we can go in now and edit our image texture. Go to the diffuse, edit texture, and you'll see here, here we see the actual mesh there overlaid with part of the model. So all I want to do now is, should be able to drag and drop the wood grain on here. So essentially what this white stuff that you see on there is the actual flat patterns of the mesh that we have. So I simply want to just make sure that I have all of those covered as I apply this. Checkbox that. And we'll see now that we have a wood grain applied to that model. One thing to just kind of mention on this as we think about it here is that this is where I think Photoshop tends to leave a little bit more to be desired, and our ability to control how the image wraps over the mesh is a little bit limited in Photoshop. So this is where things like Rhino are big, and we can actually bring in like logos and decals and things and drop them on parts, and we can select whether we want the image to tile over and over or whether we want the image to mirror or duplicate or blow or shrink. So a lot more capability in the other tools out there, but I think this works for some of the basic texturing things that you might need to do. So I have the flat pattern there, and let me see if it will let me rotate it. So yeah, we have some representation of a wood grain there. If it doesn't look sharp, this might be because I just kind of grabbed a random image here, and I don't know how high resolution it was or wasn't. I didn't really pay attention. This is sort of one of those garbage in, garbage out sort of things. So if you really want a high fidelity print, we need a high fidelity image that we're applying to the surface. So assuming this was maybe higher resolution, we can kind of use our imaginations there. So now we'll go to hit the 3D print button, and it's repairing the meshes and eventually going to get us to our export dialog box. I've closed SolidWorks, so hopefully this doesn't take quite as long as the globe, but be patient and I'm sure it will work out for us. So there we see that, and part size 3 by 3 by 3/4, exactly what we want. Export that. We got to give it a name. We'll call it globe base. there we see the representation. Let's now go over to GrabCAD Print, add a model for the globe base. And there we see it. Okay, we have our kind of a detent for the globe on the bottom there. Let me just rotate twice around X. Ought to give us a full 180 rotation. And there we see the wood grain base for that globe. So, looks maybe even better in GrabCAD Print than on the Photoshop display window. You know, for first glance, I would say that might pass as wood. And of course, after this prints, the globe will sit right in there. Jumping back to our slide, what I just want to show here, we've kind of already looked at, you know, I've imported 2 VRML photos. Now I just want to import a more complex VRML photo. So you might have seen a Stratasys example file for a gear shifter. This one has, you know, like sport on there and images like a button would have. It's got wood grain, it's got leather, it's got stitching, it's got all kinds of different stuff that, you know, if we really take this whole texturing thing to the max, I think can take it to 3D Studio Max. This is the type of thing that customers would be doing. Again, I don't have 3D Studio Max. I've never used it and would not be comfortable doing a demo on it. But, you know, if that is something you use, and a lot of industrial designers, graphic designers use this quite frequently, they would be able to produce these types of models. So let me go ahead and add that. And so for this, this is a gear shift model. So as I import this and it's thinking, what I want to point out is just looking at the files that are in there, we'll see that with this, we have the gear shift, the sport VRML, but look, there's multiple different types of wood grain. There's this sport graphic for snow, or all these different sort of variations. And this is actually for the whole host. They have about 5 different versions of this. The wood grain is the texture on there. So this VRML is mapping to all of these different images that we see on the screen in order to produce this. So now that it's on there, there we see it. I'm going to rotate it around Z to show something. So the one element is the clear visualization on this is a little bit screwy. I mentioned that for shell-based STLs, we get nothing. For the VRML, it's got some representation of the alpha channel, but because the graphic is applied backwards to the underside of that, it's tough for us to see. But, you know, we can see there that sport SPORT image and 4x4, and we can see that is captured on there. So again, just jumping back, we can see that's the same as, I think, this image right here. That iSport image is again captured on the underside of this part. If I roll it around, maybe I can pick it up. Anyway, so the visualization is a little bit tough. I know this is one of the things that GrabCAD has identified as something to work on. So in order, you know, what they're really shooting for is what you see is what you get. And obviously what we see here is not a completely accurate representation. Let's see if I can find the actual one here just so you guys can see how cool it is. And this J750 gear shift image search. So there we see them, and we see how amazing this actually comes out looking in real world. And that's obviously a little bit of a deviation from what we're seeing on the tray here, but take my word for it, that is it. For the last portion of this, let me pull up the PowerPoint again. I want to talk about just hard color proofing. And what hard color proofing is, again, I mentioned earlier, it's matching to a specific color. One of the challenges where, let me just show an example here. I like this. So what this is on screen, this represents a color gamut. So think of the outer circle there as the visible light spectrum. Within that spectrum, these different coloring methodologies are, you know, able to define portions of the visible light spectrum. You can see that RGB is fairly robust, but there's portions of Pantone colors that fall outside of RGB. And of course, obviously on the inverse of that, there's portions of RGB that fall outside of Pantone. This here in the center we see as a CMYK color palette. We'll just imagine this is the J750 color palette. It's not an actual representation. We do a better job than this CMYK, but pretend it is. So as we get, you know, maybe specify an RGB value, and that gets mapped into something that we can actually print within the printable palette. Sometimes there's a little bit of a deviation, and oftentimes we might print a Pantone and it comes out and we decide, you know what, that's not bright enough, that's not intense enough. So what we find is that we need to try different variations to really dial in the exact color. with that, Stratasys made this pretty cool tool they're calling the color swatch generator. There's the link there. If you want to take a note here and write this down, you certainly can. After this presentation, if you email to me, I'll send you the link. But the way this swatch generator works is we specify a color, whether it be hex value, LAB, RGB, some methodology. So let me find a Pantone color. Let's just pretend marketing says they want some variation of forest green. Google will do forest green Pantone. So they specified Pantone 357C, okay? So here you see the equivalents in CMYK, hex, etc. For this exercise, I'll go in, let me just use the hex. 215, 732, and we'll go hex. And then we hit create on the swatch. And what this does is based on, this range of areas here, this comes up with the things near in color to that specified value that we just gave it. And then this actually gives us, a color key here. And if we want to shrink or increase the range of colors, that's certainly options we can do. We can adjust the hue, brightness, etc., depending on how many options we want. And then we have this color key here. So now each of these tiles you'll see has a number. Each of these numbers has the hex value associated with it. And essentially what we're going to do is create a VRML file right now of this actual swatch here. And then after we can maybe go back to marketing and say, hey, which one is closest to what you're looking for? And they might say, it's number 18 is the one. And for future reference, we know that if we grab this hex value and then are ultimately going to plug it back into, let me just grab a shell on this. I could, bam, recapture that on a future reference going forward. Again, that's just showing how we're supposed to use this. So what we'll do is go ahead and download the swatch. If I go into this folder here, we'll see 7-zip, extract files. And there we see the 2D image file associated with this swatch, and then the VRML. So to actually build it now, it's as simple as open this up, drag, drop, and we should see our, boom, this is the tile coming right into there. So the underside, if you're familiar, if anything's in contact with support, it's going to be matte. Anything on the top is going to be glossy. I would print this in glossy so we can see a visual of what matte and glossy is going to look like on the same tile swatch there. With that, there's the tray. Again, all the different methods, shell-based, assigning colors right in SolidWorks, creating simulated textures in SolidWorks, actually applying textures to meshes in Photoshop, bringing in complex VRML files, doing hard color proofing using the swatch generator tool. There we see the single tray showing everything that we've just highlighted. What I like about this here is because we're printing in a full color configuration, cyan, magenta, yellow, black, white, clear, literally all of these projects can be done at the same time as a part of the same build. This is one of the distinct advantages over a Connex 3. We could certainly do this on a Connex 3. In fact, maybe it'll let me switch. Connex 3s do VRMLs, so let me add a template printer just to show what Connex 3 people might see. Object 500 Connex 3 select. And I have to go and adjust my tray, change materials. So we see these are not color materials, but if I go with Vero Yellow Vivid, Vero Magenta Vivid, Vero Cyan Vivid, and save that, we'll see that we can do all these things that we've just highlighted, but the problem is that the Connex 3 causes us to work with a very tiny color gamut. Notice the challenge here, because we don't have white, we don't have clear, we don't have black. Our clear stuff is now no longer clear. Our white stitching is no longer white. So that's the obvious limitation to the Connex 3 in its standard form. With that, let's jump back over to the methods we looked at today. There's all 6, and I think we've covered each and every one of those. I will go ahead and call this a wrap here. There in the left-hand corner, you see all of my contact information. If you want to reach out to me directly or have any questions that you think of after the fact, don't hesitate to reach out to me any of those ways there. Have a great day, guys. Thanks for attending. I hope you found this seminar quite valuable for you.